If f prime of x equals x minus 1 times the quantity x plus 4 squared, find all values where f of x is concave up and increasing. So let's deal with that guy first. Okay, when something is increasing, what you do is you take the function, you find the critical points, and you find out where the derivative is positive. Okay, so I already have the derivative, so I can find the critical points. So the critical points are going to be found by setting this equal to 0, x minus 1, x plus 4 squared, and finding out what my critical points are by doing the zero product property. So x equals 1 will do it, and negative 4 will do it. So let's make a sign graph for f prime of x, and this will help me find out where this guy is increasing. So my magic numbers were negative 4 and 1. So what I can do is I can plug in negative 10, I can plug in 0, and I can plug in regular 10. So f prime of negative 10 is going to have me doing, and this is what I'll do. I don't care about the numbers. I care about whether it's positive or negative. So this will be negative 10 minus 1 is a negative number. Negative 10 plus 4 is also going to be a negative number. Square that. Negative times a positive is going to be negative, so you are negative. Okay, so not increasing there. Let's plug in 0. F prime of 0 is going to be 0 minus 1, which is negative, 0 plus 4, which is positive, squared, and a negative times a positive is a negative again. So there's no, there's a critical point, but there's no like max or min going on here because it goes from negative to a negative. But that's not what I'm supposed to do. I'm supposed to find out where this is increasing. So let's plug in 10, and that's going to be 10 minus 1, which is positive, 10 plus 4, which is positive, square it is positives all around. So you are finally increasing. So this is increasing on the interval 1 to infinity. Now I have to find concavity, which requires me to take the second derivative, and in this case I want concave up, finding out where it's positive. All right, so in order to do the second derivative, I'm going to use product rule. So u would be my u would be my v. So u prime would be the derivative of x minus 1, which is 1, and v prime would be, good old chain rule. So you drop down the 2, keep the inside, and then multiply everything by the derivative of the inside, which is just times 1, so I'm not going to change anything there. All right, so f double prime of x is going to equal u prime v, which is u prime, which is 1, times x plus 4 squared, plus v prime u, so 2 times x plus 4, u, which is x minus 1. Ugh. All right, so I'm probably going to have to do some foiling. Unless I want to do this instead. Watch what I do. This is me thinking outside the box. That 1 is not necessary. Okay, that 1 is not necessary. I have an x plus 4 and an x plus 4 in common with both, so let's pull it out. X plus 4. That leaves me with an x plus 4 here, and a 2 times x minus 1. Okay, so by the way, that's f double prime. I don't know if I remembered to do a second thing there. Yeah, I think we're good. F double prime of x is going to equal x plus 4. So this will be x plus 2x, so 3x, and then 4 minus 2 is going to be plus 2. So setting that equal to 0, I have inflection points at x plus 4, 3x minus 2. Let's be cute here, negative 4. If I add 2 divide 3, I get 2/3. Okay, so let's make a sign chart involving the numbers for negative 4 and 2/3. So I can plug in negative 10, I can plug in 0, and I can plug in regular 10. Okay, so let's do the same thing that we did here with that guy and do f double prime of negative 10. That's going to be, if I'm going to use this equation right here, that's going to be negative 10 plus 4 is negative. Negative 10 times 3, that's going to be negative still. So a negative times a negative is a positive. So your positive, which is concave up, okay, I'll put positive because I'm trying to be consistent, not just the plus sign. Positive. If I plug in 0, f double prime of 0, I get 0 plus 4, which is positive. 0 minus 2, which is negative, so you're negative. And if I plug in 10, I get positive. And then 3 times 10 is 30. 30 minus 2 is still positive, so positive. So I want concave up. You're concave up here, and you're concave up here because of the f double prime sine graph. So I'm increasing from 1 to infinity, and I'm concave up from negative infinity to negative 4 union, and then 2/3 to infinity. So kind of a mess of a problem. And when I say kind of a mess of a problem, it's a mess of a problem, just like I am making a mess trying to circle it. But there you have it. Concave up here, increasing there, fun everywhere.